Hi everyone, for this lesson we'll take a look at the hypotenuse leg or HL theorem. So in order to use this theorem you need to have two right triangles, and we have two right here, triangle ABC and another right triangle EFG. Now the hypotenuse leg theorem states that if you have the hypotenuse of one right triangle, so AC here, is congruent to the other hypotenuse of this triangle, which is EG, and we also have one pair of congruent sides. So let's say that AB, side AB, is congruent to side EF. So if you have the hypotenuse and a leg of a right triangle that are congruent to the hypotenuse and leg of the other triangle, then that's enough to prove that triangle ABC is congruent to triangle EFG by using the HL theorem. Alright, so let's take a look at this example. We have two right triangles. So we have right triangle ABC and the other right triangle is DCB. And it's given that the hypotenuse of triangle ABC is congruent to the hypotenuse of the other right triangle DCB. And we want to find out if triangle ABC is congruent to triangle DCB. Now if we look at segment BC or side BC, we know that BC, this side here, is congruent to BC, and that's because of the reflexive property of congruence. Okay, so since we have the hypotenuse and a leg of this right triangle that are congruent to the hypotenuse and leg of this right triangle, then we can use the HL theorem to prove that these two right triangles are congruent. So we can erase this question mark and we can say that triangle ABC is congruent to triangle DCB. Alright, so this wraps up the lesson on the hypotenuse leg theorem, also known as the HL theorem. And we're still happy.